Children, once again, welcome to Physics with Sanu, Healing Medical Aspirations. See, in this video, we are going to discuss important previous year questions from work, energy and power. See, this chapter is generally a simple chapter and you can expect see two questions from this chapter. Okay, now see first question. A uniform force of 3I plus J Newton acts on a particle of mass 2 kg. The particle is displaced from initial position vector is given and final position vector is also given. See, what you have to do is, see, final position vector minus initial position vector will give you the displacement vector. Means 4I minus 2I, that is 2I. Then 3j, here there is no j component, so 3j, that is the j component, and then minus k, that is minus 2k. So this is the displacement vector. And the force vector is given as 3i cap plus j cap. We have to find the dot product. How do you find the dot product? You have to find the product of corresponding components. Means I component of the force and I component of the displacement. Here we have 3 and 2, so it is 3 into 2. Here the j component is 1, here it is 3, so 1 into 3, 3. Here the k component is 0 and here it is minus 2, so 0 into minus 2, that is 0. So we will get 6 plus 3, 9 joule. Okay, so this is the correct choice, right? And now let's see the next question. A body of mass 3 kg is under a constant force which causes displacement s in meters in it, given by the relation s equal to 1 by 3 t square, where t is in seconds, work done by the force in 2 seconds is. See, work done equal to change in kinetic energy. Here we have mass equal to 3 kg and displacement is given as 1 by 3 t square. So its velocity will be differential of this displacement, ds by dt, 1 by 3 into 2t. Okay, that is the velocity. See, we have to find the work done in first 2 seconds. When t equal to 0, you put, see, velocity v equal to 2 by 3 into t. If you want to find the velocity at any time, you have to put that time in this equation. Okay, so the velocity when time equal to 0 is 0. Velocity when the time equal to 2 seconds, that will be 4 by 3 meter per second. Okay, now work done equal to change in kinetic energy, means final kinetic energy minus initial kinetic energy. So half mv square minus u square. Okay, so initial velocity 0, kinetic energy 0. So the work done will be final kinetic energy or half mv square. Half into mass is 3 kg, velocity is 4 by 3 whole square. So that is 16 divided by 6, or we can write 8 by 3. 16 by 6 means 8 by 3. So this is 8 by 3 joules. Okay. Now let's see the next question. 300 joule of work is done in sliding a 2 kg block up an inclined plane of height 10 meter. Okay. The work done against friction is. Okay. See, when it is lifted, see, by sliding this along an inclined plane, it gets lifted to a height of 10 meter. Okay, yeah, and mass is 2 kg. The increase in gravitational potential energy will be mgh. Okay, see, the total work done equal to 300 joule, of which some work will be done against friction, that will be dissipated, and the remaining will be stored in the body as its gravitational potential energy as mgh. So total work done equal to work done against friction plus increase in gravitational potential energy. So work done against friction, we will get 100 joule. Okay, so this is the correct choice. Okay, now let's see the next question. Yeah, we have again a force displacement graph and we want to find the work done. Here also again it is a trapezium and area under the graph will give you the work done. See, we have two parallel sides, this is of see 3 units and this one is 6 units. Upper side is 3 and this lower side is 6. So average will be half into 3 plus 6 and separation between them is 3 units. Okay, so half into 3 plus 6 into 3. Okay, and that is equal to 13.5 joule. Okay, see, this is 3 plus 6, that is 9 into 3, 27 divided by 2. Means half of 27, it is equal to 13.5 joule. right? See the next question, the position dependent force, okay, acts on a small body of mass 2 kilogram and displaces it from x equal to 0 to x equal to 5, work done in joules is. See here the force is not constant. If the force is constant, you can simply find the work done as the dot product of force and displacement. When the force is not constant, you will have to integrate. Okay, so let's integrate force with respect to x from 0 to 5. This is the expression for the force. So the integral of 7 will be 7x, integral of 2x will be x square, and integral of 3x square will be x cube. When you evaluate it from 0 to 5, how do you evaluate? 0 is called lower limit and 5 is called upper limits. Okay, see we have see this equation 7x minus x square plus x cube. See this is actually 7x minus x square plus x cube. Okay, this is to be evaluated from 0 to 5. What to do? You have to put this upper limit 5 for the variable x. Find the value. What do we get? We will get 7 into 5 minus 5 square plus 5 cube. Okay, then we have to put this 0 lower limit for the variable x. Okay, all the terms will become 0. So the value obtained after putting the upper limit minus value obtained after putting the lower limit. Okay, that will give you the integral value. So that we have got 135 joules. Okay, so 135 joule, right? Okay, now see this is a simple question. But it is a question that you can expect many times. It is asked for NEET. The potential energy of a long spring when it is stretched by 2 centimeter is U. If the spring is stretched by 8 centimeter, the potential energy stored in it will be. See, this is the expression for potential energy, and see potential energy is proportional to x square. So the potential energy is U when the extension is x, and U dash when the extension is x dash. So U dash by U will be x dash by x whole square. X dash is 8 centimeter and x is 2 centimeter. So 8 by 2, that is 4. 4 square is 16. So U dash, U dash will be equal to 16U, this one. Okay. Now see, we have a typical question. That is, if the kinetic energy of a particle is increased by 300%, the momentum of the particle will increase by. See, original is always 100%. Original momentum, that is 100%. So 100% momentum means 1p. 100% kinetic energy means 1k. Okay, 1k. Here k is used to represent kinetic energy. Okay, so 200% of kinetic energy means 2k. 150% means 1.5k. 80% means 0.8k. Okay, so to convert a fraction to percentage, you have to multiply by 100. To convert percentage to fraction, you have to divide by 100. Okay, now see the question. If the kinetic energy of a particle is increased by 300%, kinetic energy is originally 100%. Now it is increased by 300%, means it becomes 400%. See, 100% is 1k. 400% will be 4k. Okay, so in short, kinetic energy is changed from k to 4k. Okay, what is the change in linear momentum? Here, P, linear momentum equal to under root 2m into k, kinetic energy. Mass does not change. So P proportional to root k. So P dash by P equal to root of k dash by k, and k dash equal to 4 times the initial kinetic energy. So this will be root 4 and it is equal to 2. So we will get P dash equal to 2p. Original linear momentum is 1p and it is 100%. Now the linear momentum is 2p, means it is 200%. Means it is increased by 100%. Okay, so the momentum of the particle will increase by 100%. Okay, next question. See, a rubber ball is dropped from a height of 5 meters on a plane where the acceleration due to gravity is not known. On bouncing, it rises to 1.8 meter. The ball loses its velocity on bouncing by a factor of. See, when a ball is released from a height h, its initial potential energy is mgh, and at the bottom its kinetic energy is half mv square. then half mv square equal to mgh. See, if the velocity at the bottom is half mv square and it goes up to a height mgh, then also half mv square at the bottom equal to mgh at the top. Okay. Now from here we will get a v equal to root of 2gh. Okay. See, initially it falls from a height of 5 meter and strikes the ground with a velocity say v. And after bouncing, its velocity loses by some part. Okay, and suppose it bounces back with a velocity v dash and goes up to a height h dash where its velocity falls to 0. When released from h, it strikes with v. When it starts from the bottom with a velocity v dash, it goes up to a height h dash. Okay, in both the cases v proportional to or v equal to root of 2gh or v proportional to root h. So v dash by v equal to root of h dash by h. Okay, h dash is 1.8 and see h is 5. Okay, that we can write 18 by 50 or say 36 by 100 and it is 0.36. Its root will be 0.6. Okay, so v dash equal to 0.6 v means it is 3 by 5 v. Final velocity is 3/5 of initial velocity. 3/5 of initial velocity means it has lost 2/5. Okay, now the question, the ball loses its velocity on bouncing by a factor of 2 by 5. 2 by 5, 2/5 of initial velocity is lost. Okay. Now see, we have another question. An electric lift with a maximum load of 2000 kilogram, lift plus passengers, is moving up with a constant speed of 1.5 meter per second. Okay, the frictional force opposing the motion is 3000 Newton. The minimum power delivered by the motor to the lift in watts is. Okay, and see, the power is force into velocity. Okay, the force is see, the load is 2000 kilogram. Okay, so the force that is to be opposed is the gravity plus friction. Gravity means the weight, 2000 kilogram means into g is 10, so 20,000, and the friction is 3000. So the total force to be opposed, that is 20,000 weight plus 3000 friction, 23,000, into velocity is given as 1.5. So 23,000 into 1.5, that is 34,500 watts. Okay, now let's see the next question. Here, water falls from a height of 60 meter at the rate of 15 kilogram per second to operate a turbine. Okay, the losses due to frictional forces are 10% of the input energy. How much power is generated? Okay, so only 90% will be generated output. Okay, so mgh, that is the energy when a mass m falls from a height h. Okay, divided by t, that is the power. Okay, so this much, see, the output power will be only 90% of this, means into 90 by 100. Okay, of which this m divided by t, that is the mass per unit time, and it is given as 15 kilogram per second. Okay, and g is 10. Okay, height is 60 meter, m g, height is 60 meter, and we have to find 90% of it. So it will be 8.1 kilowatts. Okay, it is 8100 watts or 8.1 kilowatts. Okay, a particle of mass m is driven by a machine that delivers constant power of k watts, small letter k. Okay, if the particle starts from rest and the force on the particle at time t is, okay, if it starts from rest, see, work done equal to change in kinetic energy, or it will be equal to final kinetic energy. So half mv square, that is final kinetic energy, minus 0 initial kinetic energy. Okay, that is the increase in kinetic energy equal to power into time. Okay, from this we will get v equal to under root 2 kt by m. Okay, now force equal to power divided by velocity. Okay, because power equal to force into velocity, power is given as k, and velocity we have got under root 2 kt by m. Okay, now see, k divided by root of kt by m means we will have to multiply with the reciprocal of this term in the denominator. Okay, so it will be this k we can take into the inside the square root sign, so it will be mk square, okay, divided by 2kt, of which see this much is constant, okay, and t inside the root and in the denominator, means it is t raised to minus half. Okay, so let us say the force is proportional to t raised to minus half, or it is under root mk by 2 t raised to minus half, this one. Okay, now let's see the next question. The heart of a man pumps 5 liters of blood through the arteries per minute. Okay, that is the rate of flow, means it is the area into velocity, 5 liters per minute. Okay, okay, and the pressure is 150 millimeter of mercury. Then the power of the heart is, okay, power is force into velocity, force into velocity. Okay, this h rho g is the pressure into area, that is the force into velocity. Okay, h rho g pressure is equivalent to 150 millimeter of mercury. 150, to convert millimeter into meter, you have to multiply by 10 raised minus 3. Okay, density of mercury is 13.6 into 10 raised to 3. Okay, h rho, then g 9.8. Then see h rho g, I have substituted the values. Now I have to put this AV, area into velocity, that is equal to rate of flow or volume per second, and it is given as 5 liters of blood per minute. Okay, see how do you convert this liter into meter cube? 1 liter is equivalent to 10 raised to minus 3 meter cube. So 5 liters, this must be in SI system. 5 liters equivalent to 5 into 10 raised to minus 3 meter cube per minute. Means to convert it into per second, we have to divide by 60. So 5 into 10 raised to minus 3 by 60. Okay. Now this we will get, this is equal to 1.7. Okay, 1.7. How can we do it? See, this 10 raised to 3 and this 10 raised to minus 3 can be cancelled. Okay, now let us see this 150 and 60 we can cancel. Okay, now I will show you. See, this can be divided with the 30. Okay, this is also 30. Here it will be 5 and here it will be 2. Okay, now this see, take this 9.8 as a 10. Okay, then this 5 into 5, that is 25, into 10, that is 250. It can be written as 1000 divided by 4. That 1000 and 10 raised to minus 3 can be cancelled. Then by 4. By 4 and 2, that is 8. Okay, so 13.6 divided by 8. Okay, so it is approximately 13.6 divided by 8 means it is approximately 14 by 8. Okay, see 14 by 8 that will be equal to 7 divided by 4. 7 divided by 4 equal to, that is 3.5 by 2, and it is equal to 1.75 approximately, and here we have 1.7 as the answer. Okay. Okay, now let's see the next question. How much water a pump of 2 kilowatts can raise in 1 minute to a height of 10 meter? See, the power is work done divided by time. Work done in this case is mgh divided by time. Okay. So mass of water that can be lifted in time t, it will be pt by gh. Power is given as 2 kilowatts, means 2000, 2 into 10 raised to 3. Time is 1 minute, 60 seconds. G is 10 and height is 10. Okay, so here we will get that is 1200 kilogram. See, in case of water, 1 kilogram water equal to 1 liter water. So 1200 kilogram means 1200 liters. Okay, 1200 liters. Okay, now next question, let's try. Now children, we have another example, a typical example. See, a particle of mass 5m at rest suddenly breaks into 3 fragments. 2 fragments of m each move mutually perpendicular directions with speed v each. The energy released during the process. See, before explosion, this body is at rest and its total linear momentum is 0. After explosion, there are 3 fragments. See, the vector sum of the linear momenta of these 3 fragments must add to 0. So, if we find the vector sum of the linear momentum of 3 fragments, it should be 0. Means the linear momenta vectors of these three fragments must be represented as the sides of a triangle taken in order. Okay, we have two fragments, each of mass m moving with velocity v. So first fragment, its linear momentum is mv. Second fragment also its linear momentum mv but perpendicular. Okay, when we draw the linear momentum vector of the third fragment also, it should form a triangle. Okay, so the linear momentum vector of the third fragment must be like this. See, by Pythagoras theorem, if this is mv and this is mv, this will be mv root 2. I have told you earlier. See, if this is 10 and this is 10, no doubt this is 10 root 2. If this is x and this is x, this will be x root 2. Here we have mv and mv, so this will be mv root 2. And this represents the linear momentum of the third fragment. See, the total mass was 5m, of which mass of this is m and this is m, total 2m, so the remaining will be 3m. Okay, mass of the third fragment is 3m and let it be its velocity v dash. Okay, then we will get v dash equal to v root 2 by 3 from here. Okay, the question is, what is the energy released? Means total kinetic energy of the three fragments. See, first fragment is of mass m and velocity v, its kinetic energy half mv square. Second is of mass m and velocity v, again kinetic energy half mv square. Third is a half, mass is 3m and velocity v root 2 by 3 whole square. This root 2 square is 2 and this 2 in the denominator can be cancelled. See, then v by 3 whole square will be v square by 3 square of, see, out of this 3 square, 1 3 can be cancelled with this 3. So the energy of this part will be mv square by 3. Here half mv square, again half mv square. So if we take mv square as a common factor, what see remains inside the bracket? Half, again half, then 1 by 3. Okay, half plus half, 1 plus 1 by 3 will be 4 by 3. So 4 by 3 mv square. Right. Now children, we have another example here. On a frictionless surface, a block of mass m moving at a speed v collides elastically, means kinetic energy will be conserved, with another block of mass capital M, okay, means an equal mass, which is initially at rest. After collision, the first block moves at an angle theta to its initial direction with a speed v by 3. The second block speed after collision is, see, total kinetic energy will be conserved, half mv square. That is the initial kinetic energy. Initial kinetic energy, if only the first body is moving, second body is at rest. So after collision, see, the first body moves with a velocity v by 3. That angle or direction is irrelevant. Okay, so half into mass into v by 3 whole square. And suppose the second body is moving with a velocity v dash, so its kinetic energy will be half into m into v dash square. Okay, from here half m is common to all the terms, that can be cancelled. Then v square, and here it will be v square by 9. When it is taken to the left, it will be minus v square by 9. Okay, and on the right side v dash whole square. So this will be 8 v square by 9 equal to v dash square, and v dash we will get see root of 8 by 9, or 2 root 2 divided by 3 times v, 2 root 2 by 3 into v. So this will be the correct answer. Okay, okay children, see, we have a shell of mass 200 gram is ejected from a gun of mass 4 kilogram by an explosion that generates 1.05, means 1050 joule. 1.05 kilojoule of energy means 1050 joule. Okay, initial velocity of the shell is, initial velocity of the shell is, means after traveling some time, its velocity will definitely get reduced. Okay, that's why initial velocity we have to find out. See, this is really beautiful. Okay, and see, before firing, this bullet is inside the gun and the gun is at rest. So its total linear momentum is 0. And after firing, bullet will be moving in the forward direction. See, as the total linear momentum before firing is 0, the total linear momentum after firing also should be 0. So if the bullet moves in the forward direction with some momentum, then the gun must be moving backward with the equal linear momentum. So the gun and the bullet are of equal linear momentum in magnitudes. Okay, now see, we have to find the kinetic energy. See, kinetic energy K in terms of linear momentum P and mass M is given by K equal to P square over 2M. P is the linear momentum, K is the kinetic energy. Here we have got two bodies, bullet and the gun. Both the bullet and gun have equal linear momentum in magnitudes. So when we consider shot and gun, see both the bodies are of the same linear momentum P square P. So P square by 2 is same for both the bodies. As we move from one body to the other, P square by 2 will not change. It's a constant. So this equal to and constant, we can replace that equal to and constant by proportional to, so K proportional to 1 by M. Or let us say the kinetic energy is inversely proportional to mass. So the kinetic energy of the shot divided by kinetic energy of the gun must be ulta. In the reverse order means mass of gun divided by mass of shot. Okay? And the mass of gun is 4 kilogram. And mass of shot is 200 gram, means it is 0.2 kilogram. Okay, multiply both numerator and denominator by 5. You will get 5 into 4, 20, 5 into 0.2, that is 1. Okay, now the kinetic energy of the shot and kinetic energy of the gun are in the ratio 20:1. Okay, now see, by an explosion that generates 1.05 kilojoule of energy, means 1050 joule of energy. That is the total kinetic energy of the gun and the shot together. Okay, means Ks plus Kg, that is 1050. That total kinetic energy 1050 must be divided in the ratio 20:1, means it is to be divided into 20 plus 1, 21 equal parts. When 1050 divided by 21, that is equal to 50. So the total kinetic energy 1050 is to be divided into 21 equal parts. Then each part will be 50, 50, 50, 50, 50, like that 21 parts. Okay, kinetic energy of the bullet, kinetic energy of the shot is 20 parts. And kinetic energy of the gun is only 1 part. So kinetic energy of the gun is only 50 joule. Okay, and kinetic energy of the shot will be 1000 joule. This 50 and this 1000 are in the ratio 1:20. Everything fine, beautiful. Okay, now see, we have got kinetic energy of the shot as 1000 joule, or let us say 1 kilojoule. We have to find the velocity of the shot. See, kinetic energy of the shot is half, mass of the shot is 200 gram, means it is 0.2 kilogram, and velocity v, so half 0.2 v square, that is equal to 1000, and this 0.2 by 2 is 0.1. When it is taken to the right, it will be 1000 by 0.1, means it is 10,000. It's a perfect square. What is the square root of 10,000? That is 100. So the initial velocity of the shot is beautiful, that is 100 meter per second. Okay, children, we have yet another wonderful example. Okay, a bomb of mass 30 kilogram at rest explodes into two pieces of masses 18 kilogram and 12 kilogram. Okay, the velocity of 18 kilogram mass is 6 meter per second. The kinetic energy of the other mass is, see, before explosion, this 30 kilogram bomb is at rest. Its total linear momentum is 0. So after explosion, there are two fragments. Total linear momentum of these two fragments must be 0. Means they must be moving in opposite directions with equal linear momentum. Okay, see, 12 kilogram moving back with the velocity v, and this 18 kilogram moving forward with the velocity 6. So from here 12v equal to 18 into 6 in magnitude. Okay, so we will be this 12 and 6, when we cancel it, here we will get 2v equal to 18 and v equal to 9. Okay, we have to find the kinetic energy of this 12 kilogram piece. The expression is half mv square, half mass is 12 kilogram and velocity is 9 meter per second. So it will be, see, 9 square is 81 and 12 by 2 is 6. 81 into 6 will be 486 joule. Right? We have another question. A bomb of mass 1000 kilogram means 1 kilogram, 1000 gram is thrown vertically up with a speed of 100 meter per second after 5 seconds. See, when a body moves vertically up, it is being pulled by the earth. So it experiences an acceleration that is due to gravity, and it is equal to 10 meter per second square. What does it mean? See, as it moves up, the motion is being opposed by the attraction of the earth. So its velocity changes by 10 meter per second. Means in each and every second its velocity will change by 10 meter per second. When it goes up, velocity will decrease by 10 meter per second in every second. So after 5 seconds, its velocity will decrease by 5 into 10, 50. Okay, initial velocity was 100. After 5 seconds, its velocity will be only 50 meter per second in the upward direction. Or let us say v equal to u minus at or minus gt. Why minus gt? See, this initial velocity u is directed upwards. That I have taken positive. Then the acceleration that is directed down should be taken as negative. If you don't like that convention, you can take in the other way also. If you decide to choose this u, initial velocity, which is directed upward, as negative, then acceleration due to gravity you can take it as positive, or you should take it as positive. Okay? Means in motion under gravity, any direction, upward or downward, you can take it as positive. Only thing is that opposite should be negative. Okay. Now see, after 5 seconds its velocity will be 50 meter per second and is directed upwards. Okay. Now let me apply the law of conservation of linear momentum. It is valid for any collision. It is valid for any explosion. Okay. Now let's see 1 kilogram. Let me convert because the fragment masses are given in gram. So let me represent this also in gram so that we can easily cut down. Okay. So this is 1 kilogram means 1000 gram initial mass, and its velocity is 50. That I have taken positive, indicating, see, upward direction I have taken positive. Okay, that's why this upward velocity 50 meter per second I have taken positive. Okay, now after explosion, one fragment which is of mass 400 gram moves down. Okay, this upward 50 I have taken positive, so the downward 25 must be negative. Okay, so if the mass of one fragment is 400 and there are only two fragments, then the mass of the other fragment must be 600 and its velocity is unknown. Okay, this is the momentum of one fragment and this is the momentum of the other fragment. Sum of these two must be equal to the total linear momentum just before explosion. Okay, so we will get throughout you can divide by 200. So here you will get 5 into 50, and here you will get this 2 into minus 25, that is minus 50, and here you will get, when divided by 200, 3 into v, 3v. That v is the unknown. When this minus 50 is taken to the left, already there is 5 into 50 means 250 plus 50, that will be 300. 3v equal to 300. So v will be equal to 100 meter per second. That we have got as positive, and we have taken upward direction as positive. So it will be moving with 100 meter per second in the upward direction. Okay, means the second choice. Now see, we have a really beautiful question. A metal ball of mass 2 kg moving with a velocity of 36 km per hour, means 10 meter per second, has a head-on collision with a stationary ball of mass 3 kg. Okay, if after collision the two balls move together, means after collision they stick together and the combined mass moves with a common velocity, the loss in kinetic energy due to collision is delta K equal to half m1 m2 divided by m1 plus m2 into u1 minus u2 whole square. Okay, see, you can enjoy the beauty of this formula. See, and this is really beautiful. And see, suppose a capacitor C1 charged to a voltage V1, another capacitor C2 charged to a voltage V2. When these two capacitors are connected in parallel, they will attain a common voltage. Just like here the two bodies will attain a common speed, and that common speed is given by V equals m1 u1 plus m2 u2 divided by M1 plus M2. And in case of capacitors, the common potential difference voltage is C1 V1 just like M1 U1 plus C2 V2 just like M2 U2 divided by C1 plus C2 just like M1 plus M2. See, in case of capacitors also there will be some loss of energy, and the expression is really beautiful, and it is delta U. The loss of potential energy is half C1 C2 by C1 plus C2 into V1 minus V2 whole square. Okay. Anyway, see here we have the second body at rest before collision, so U2 equal to 0. And first body was moving with a velocity 10 meter per second. It's given as 36 kilometer per hour. Okay. So the masses are 2 kilogram and 3 kilogram. 10 minus 0 whole square. So it will be half 6 by 5. Then 10 square. This 2 into 5 is 10. This 10 square by 10 will be 10 only. 10 into 6 is 60 joule. Okay. So this is the correct answer. Right.